all hooked up. 12.36, 12.37 on the multimeter, and the Arduino output is telling me 12.1 to 12.37 as well. Looks like it works. Let's figure out how I did it. Hi, I'm John, and that is Scarlett the Four-Eyed Cuda. If you've made it this far, you have just seen the intro of the Arduino data logging project that I am working on. Have its first successful implementation of a voltage sensor that has it match the sensor to the voltage meter, so I can verify that they are at least within the ballpark of traditional accuracy. So let's find out how I got there. I'll show you the parts that I'm using, where I found some of the code that I'm using, where the project is going, and any other tidbits along the way. So buckle up, let's go for a ride. So first off, what Arduino did I choose? I chose the Arduino Mega, and actually this is a clone of the Arduino Mega that's by KEYESTUDIO, and it is only 20 bucks. I'll have a link below from Amazon on it. I am not an Amazon affiliate, and I am not sponsored by any of this, but I'm just showing you the tools I used. If you want to use a different Arduino or something altogether different, hopefully this will still be a reference. But this is the product I'm using. Because it's 20 bucks, I bought two. One you'll see on a board like this, and then as the project expands, I'll switch to the other board, doing it more from a here's the project piece that we're working on, and then the other one will be the integration of this piece plus whatever the next step is. And then that'll be cumulative on that other board, because I've got a larger breadboard on it, and this Arduino is capable of doing it, but rather than moving the Arduinos back and forth, it was just easier to have two setups. The Arduino, the sensor I'm using is a voltage sensor off of Amazon. I'll have the link on that as well. Then I just have some, bodge wires. I think it's a 20 gauge wire with some barrel connector ends on it, so that I can do some simple stuff when testing. So when I say simple stuff while testing, what am I talking about? Well, I just happen to have a 9-volt battery. It also has I think it's a 2.1 by 5 millimeter barrel adapter on it, which fits perfect into my other barrel adapter. And so now I can test code and do stuff using it to test a 9-volt battery, and compare that with results from a multimeter. And if the two numbers match or good enough, then that tells me that my code is accurate and I am good to go. So let's start looking at code. So where did I find my code project? First thing I did is I did some Google searching, and I found a 0 to 25 volt voltage regulator sensor. I shouldn't say regulator, it's voltage sensor or voltage divider, however you want to look at it. It essentially has two resistors with some sensor pins and inputs. This is a schematic of it. Here's your two resistors, here's your sensor, here's your negative, and your source and ground, your common ground. And this is an example of it hooked up to a battery. And here's the code. I will put this link down in the description so you can have it. And then let's see how that looks actually in the Arduino application. All right, so here's what the code looks like inside the Arduino IDE, or Integrated Development Environment. I've put some comments for where I found the code and the voltage sensor I'm using. I define my pins and set my initial values to my inputs, my resistors that are on the unit, and I did use my multimeter to verify the values of those resistors. If they were different, I would have updated them. Resistors, I actually got really lucky with these because they measured exactly the way they show here. I have a different unit that they're a little bit off. It's like 29,950 or something. And that's where you would modify those, because resistors usually come in plus or minus 1, 2, 3, 5, half a percent, because they're mass produced like anything else. They're never 100% dead on. In the sample code, it has a voltage reference for 5 volts, and I took my multimeter and did a test to find out exactly what my reading is. So if I do that, let's turn on Mr. Multimeter and flip my camera around so that you can see. So hopefully you will be able to see all of this. So multimeter is on. I have a red wire here going to the 5 volts of the multimeter, or sorry, the 5 volts of the Arduino, and a black for the ground going to the ground side of the Arduino. And if I touch these over, you see I'm at 4.937, 4.936, 4.938 sometimes. And so what you do is you take that 4.93, you then go back to your Arduino and you say, okay, I'm at 4.937, and then I hit the go button. Here is what I call it. It's the upload button. That compiles the code and sends it to the Arduino, and then it starts to run. And now this tells you, because your voltage reference is slightly different, now your values that are being recorded are slightly different. And then if we go back to our workspace view and I say, okay, well, what exactly is this battery showing? And if I flip my leads around so I don't get a negative number, I am at 8.76, and the Arduino is telling me 8.70, 8.73 in general. So flip back to there so you can see that, and you can see there's the 8.70, 8.73. I did a test video, and one of the people said that the font size was a little small, so I made it a little bigger. Hopefully that is readable to you. If not, please make a note in the comment, and then the next video I will increase the font size again. So that gives me my accuracy values. So when I said that first test on the car, with accurate values, what I had to do is I measured these resistors on the voltage sensor, verified those, and then I had to adjust my reference voltage, because the reference voltage on my Mac, for whatever reason on that 5 volt output, it's 4.8 something, and so I had to modify that in order on the Mac version of this versus my PC version, or my desktop version if you will, that has 4.937. So when it actually gets powered on by the car versus in a more production environment, I'll have to go back and probably reset this voltage reference. And I've got a 5 volt power supply that I will be using to power all of my 5 volt items or sensors, and that's what I will use. I'll do a calibration on that, figure out what that value is, and then put in my voltage reference, and then everything will be keyed off of that. This is just the serial output, what you're seeing here. And so that, otherwise, if I turn the serial output off, it doesn't, you have no clue what's going on. So if I turn the serial monitor on, it's like off, it's like, okay, well, that's nice. What's it really doing? And in a test environment like this, it's totally fine to have the serial monitor. I will be using an external display once everything is up and working. That's on the to-do list. And having this flyby on the screen is a nice proof of concept showing that everything works. But at the same time, there is not a lot of value to it from a data logger perspective, because it's being shoved out the serial port and out the bit bucket and lost forever. The next video I will have the real-time clock and the SD card hooked up, and we'll show how those connections get made, and at the same time of how to run the program to record that data. If you read the article that I was just on, it talks about these formulas. Well, this is just your voltage reference with the value times the reference voltage divided by 1024, because this is a 10-bit DAC, and everything with computers is a factor of 2, so 2 to the factor of 10 is 1024. And then you have to take, that gives you one value, and then you have to do your conversions for your voltage divider in order to get the actual input voltage, and that's what this formula does. And this R2 and R1 are your two resistor values up from above. And the cool thing about the Arduino is, as I hover over these, it gives you the value for what those are, and it's like, oh, where did I get this 7.5 from? Oh, it tells me that, and that 7.5 is up here because that's what that R2 value is, and it just makes it easy to troubleshoot. And then I just tell it to print input voltage equals, and I tell it the input voltage with 2 decimal points, and then delay is 100 milliseconds. So then 10 times a second it's pulling this thing. From a connections standpoint, there's really just 4 connections. You've got your sensor pin going, which I have is this white one, going to A0, which is my analog input 0 on the Arduino. The ground pin connected to the ground of the Arduino, and then the voltage in and ground, or your plus and your minus of your input voltages, going to the sensor. And that is what I have here on the battery. So the battery barrel connects in, red to plus, black to minus, red to plus, black to minus, and it just works. And because this is a standalone unit, I am just using some little blue tack in order to have this stick to my breadboard. Sorry for the focus things as my hand gets in the way, but that'll keep that in place so it doesn't float around on me and cause problems later on in life. So at a very high level, that is where we are at. We have it working. We have the voltage references set. We have the voltage output fairly accurate, and I think it's within 0.03, 0.04 volts, something like that, if I remember right. At this point, let's take you to what is happening in the next episode as a preview. So what am I doing here? So here's my spreadsheet of all the different sensors I'm going to have, and this is why I wanted to use the Arduino Mega, because you can see I'll have 10 analog inputs at a minimum. And that's the voltage meter, fuel pressure, oil temp, trans pressure and temp, coolant temp, manifold absolute pressure sensor, engine RPM sensor, and 2 wideband O2 sensors. It's a V8 in the CUDA. So that'll be one for the driver's side, one for the passenger side. And then the helper items will be the real-time clock, an atmospheric absolute pressure, and then an SD card for the actual recording of the data. And you might say, isn't some of this redundant with the atmospheric absolute pressure and the manifold absolute pressure? Maybe, but how I'm going to be reading vacuum is to use the manifold absolute pressure off of the manifold, and that'll tell me how many millibars are present of pressure, if you will, inside the manifold. And then this guy, the absolute manifold pressure, will be just open. So that'll be like the reference. So reference minus manifold equals X. X, I think it's divided by 33.8 something. I'll cover that in the actual episode for it, but that's the conversion from millibars to inches of mercury, and then that will tell me what my actual vacuum is, and then we'll be able to move forward from there. So we'll have actual vacuum reading based upon the delta difference between the two pressure sensors. So I have a 5-inch display that I also have in my position, but I just not sure how I'm going to hook it up yet. I need to read more about that, but that'll be later on down the episode once all the stuff above works. Because if there's conflicts or something, then that will change what I need to use for the display. And what I mean by conflicts is if you see some things here, you can see these two all both use the same common pins between SDA 20 and SCL 21. So these are common. Luckily, these are shareable data pins. So that is a good thing. But other situations where you might have like a I2C or I2C or however you want to say it, they can have up to 4 addresses on that bus. Well, if you've got 2 things that are variable and you can't change their address, then that would be a problem. So hopefully this made sense. Please add your comments, like, share, and subscribe. I will be posting the code to the project as well as the parts that I am using, and let me know what you think, and hopefully you found a lot of value and will stay along and engaged with the rest of the project. So thank you very much. Have a great day. Take care. God bless, and have a great weekend. Bye-bye.